Our next topic is your tune collector oscillator. This is the one of the types of your oscillator circuit. We have already seen the different types of your oscillator circuit present, such like your tune collector oscillator, one of the this one, and next we see your Colpitt's Hartley, and next one is your Bean Bridge, and next one is your phase shift, and last one is your crystal oscillator. These are the types of your oscillator. Now we first focus your tune collector oscillator. To observe this one, the topics is written here means tune collector oscillator. Means the collector is the one of the terminal of your transistor. Means transistor has the three terminal. One of the collector and base and one of the emitter, three terminals. In this collector, you observe this one circuit. There is a collector. This is your base. This is your emitter. In this collector, there is a tune circuit is connected. Now here focus the transistor now connected to tune circuit. Tune circuit is a tank circuit. Also called a oscillatory circuit. Means L1 means one of the inductor and one of the capacitor is now connected to parallel. Means this is your tune circuit or a tank circuit. This is the combination. Means L1 and C1 is the parallel combination is the tune circuit. Now focus upon the circuit description. Here to observe this one means this L1 and C1 is a parallel combination, that is called the tune circuit. Next focus, this is a L2. L2 is now connected to your tank circuit or a tune circuit. How is connected? This is now work as a transformer, means L1 and L2 near about to each other, and this one is the magnetically coupled. Magnetic field around this one means whatever the induced voltage in the L1 means in this L1 across what is the induced voltage, now this appear across L2. This is work as a transformer. Now whatever the induced here means L2, this is now connected to transistor of the base terminal. One of the terminal is going to base, and next one is to observe this one. This is going to in this form, and this is also path follow, means this was going to emitter. You see here, this is your emitter, means L2 of your coils or inductor is now connected to base and emitter. This is one of the description. This is your magnetic coupled, is written here, means magnetic coupled. L2 is in the base circuit, means this is a base circuit is magnetic coupled to L1. Now next to observe this one, the resistance is the R1, R2 and RE. This one of the resistance, this one of the resistance, and this one of the. These are the for using for proper biasing. Means also this one of the emitter bypass capacitor. This also one of the bypass capacitor. C2 is also bypass capacitor. Means CE and C2 both are the bypass capacitor. Means R1, R2, RE and CE are we only consider R1, R2 and RE. These are used for biasing purpose, and CE used for the stability purpose. Overall, we include this all four component each work for as a written, also written here, means provide a biasing and stabilization of your circuit. And next one, to observe this one, your extra of your capacitor is connected. Then need to observe this is not connected in your different types of topics we already studied. Means C2 is you are not see in the previous lectures. You see one of the capacitor is now connected here, means this is now bypass this R2, means whatever the signal is now AC signal, means to flow of your AC signal now path is adopted this one, means whatever the induced here induced voltage, now this is path follow of this one, means the if this is not presented here, means the circuit is absent the C2, what happened, the R2 across the drop is present. That's why what happened, the drop of your R2 across your decrease of your whatever the induced voltage in the L2 for proper functioning and increase your gain, the this C2 is used here. This also written here. C2 provides a low reactance path for oscillations. If C2 is absent, here written C2 is absent, the feedback voltage induced of your secondary transformer. This is one of the also called a induced voltage. Induced voltage also called a feedback voltage. Means feedback voltage now directly goes to your base emitter terminal, means in this your transistor. If the C2 is not present, this now goes to follow this one path. The drop of voltage is here present, then this is not directed go your transistor. This is now induced voltage, also called a feedback voltage. Now the feedback voltage through this transistor we amplify your whatever your feedback voltage come across your transistor. If C2 is absent, means your feedback voltage not directly go inside your transistor. This is the your C2 of your capacitor property. This is your circuit description. Next, to observe this operation, this is the operation. Here whatever I explain here the component, and we now focus your working of operation. Now to observe this one circuit, first we consider initially we apply a VCC, means this is apply your VCC voltage. This is written here. Once apply voltage VCC, first switch on, means first apply your VCC voltage. Now what happened? Collector current start rising, the charging of capacitor C1 and discharging through L1 and setting up a oscillation of frequency. This is written here. Means when the VCC on, now the collector current, this is your collector current is increasing. Meaning of this one, now the VCC on, the capacitor start charging. This arrow indicate only variable. You frequency want to change, to vary this arrow mark only here, only for purpose of changing your frequency of oscillation. Just here focus only operation. Means first switch on your VCC. Now capacitor is now charged. When capacitor is charged, now discharge path of follow of this L1. Now this is L1 across the is now whatever charge is present in L1 across. Now again this is discharged through C1. Means C1 your capacitor is charging and discharging path is adopt your L1. Now also explain in this matter, in this form other way we also explain. Means when the switch on your supply voltage VCC, the capacitor is charged. Now capacitor is charged such like your electrostatic energy now stored here. Means your VCC apply, electrostatic energy is stored here. Now this is now transferred to your L1 inductor. Means electrostatic now convert to magnetostatic field. Now again this is convert to electrostatic field. This also convert to magnetostatic. These alternate process follow. That's why setup of oscillations, means particular frequency is produced by this one tank circuit. Now whatever your voltage is producing, this is now induced across your L2. Means whatever your voltage are producing, this is now induced across your L2 due to transformer action. Means this is now induced here. Now this voltage, induced voltage now connected to one of the base terminal. Now also follow their emitter rule. Means base and emitter is this L2 is induced voltage connected. This induced voltage also called a feedback voltage. Now this feedback voltage now to go inside your transistor. Now transistor work as a amplifier. Now this is now amplify your signal. Means amplify your signal means this is increase your collector terminal current. Collector terminal current is increases or your output is increasing through this transistor work as a amplifier. Means whatever your feedback voltage now is connected here, this is now amplified. This amplified output is come across your collector. Means when we set up a oscillation, suppose we set up a oscillation, this is now producing such like this. Means the amplitude is now decreasing. So what happened when feedback voltage is connected here? Now this is again amplified. Then this energy, whatever this is losses going, this is loss going, means oscillation is set up in this matter. Means the decreasing, means this is your damped oscillation, means amplitude decreasing. Means if the transistor is amplified, again the energy is now increasing. Means whatever this is decrease, now this is your increasing. Means whatever the losses is compensated by your transistor. Means this is your sustained oscillation now produced by this one. Okay, this is the operation of your collector tune oscillator circuit. This is also written here. This also written to focus. This already explained here. Means when the setup of oscillation is frequency, means when producing a oscillation. Now this oscillator circuit built into a EMF coil in L2, means the secondary of your, this is now considered the secondary winding, this is considered primary winding, means induced voltage induced here L2. Now this will be increase the magnitude of collector current due to amplifying property of transistor, means transistor work as an amplifier. Now this induced voltage means this is now amplified by your transistor. Now transistor is also output come across the collector. Now this one increase your, whatever the losses is now present, this is now maintained by the losses of your transistor. This is also written here, means the amplified collector circuit be amplified the power oscillator circuit L1 and C1 and compensating for the losses occurring, it hence the oscillation will be sustained oscillation. Okay, these are the operation. Also one of the properties we see in the Barkhausen criteria, if the output is now feedback to input, there is phase shift is come to 360. If this follow, the sustained oscillation is obtained by the that circuit. Also to focus upon the phase shift, to observe this one, means the output, means we have seen when input is applied, when input apply, now output is come, now output is now follow your feedback path, this is your feedback. Now this is also come to in this input side, means there is the 360 or a 0 degree. If this properties follow, the positive up, this is the positive feedback is follow, means 360 is come, this is the positive feedback follow, means for proper oscillation 0 phase shift or 360 phase shift is come out. To observe this one here, first one, this one, observe when the transformer action is taken here, means L1 is, L2 is magnetic couple, means whatever the oscillation is set up here now is induced in the L2. In this circuit the phase shift is obtained here 180 degree, means transformer action this is provided 180 degree shift. Now next this induced voltage now amplify your transistor. Now this is your common emitter. The common emitter transistor has the property is introduce a 180 degree phase shift, means transformer action 180 degree phase shift, common emitter property is the 180 degree phase shift. Now the total phase shift now added here 180 plus 180, now this is come 360. 360 also written as 0 degree. Now this is a work as a positive feedback, also as a sustained oscillation provided by this one, this is written here. You see here, means phase shift 180 degree provided by the L1 and L2 transformer action. You observe this one, and another phase shift common emitter transistor is 180 degree, means total phase shift now added 360. This means it is in a phase. It is in phase means the whatever the input is here, now feedback is come here the same phase, that is called in phase, means this is work as a positive feedback, means oscillator has the property of the positive feedback. This is the operation of your tuned circuit oscillation. Okay.